Montreal, Canada, Expo 67. The theme was to be man in his world, a spectacular display of his achievements in the arts and sciences. Its preparation alone would require 4 years and over 100 million man-hours of work. The master plan called for Expo 67 to be situated on man-made islands emerging from the St. Lawrence. Leading to them would be a complex of superhighways and bridges capable of transporting the 12 million visitors expected at Expo. $12 million people in 6 months is a lot of people. 12 million people in 6 months is 2 million people a month. 500,000 a week. 30,000 people an hour on peak days. Problem? How do you move 30,000 people an hour over Expo's site in comfort and safety? The answer?
Expo 67 had called for tenders, and as we gathered at our Montreal headquarters to discuss specifications and formulate our bid, we of Hawker Siddeley, Canada, knew that the competition would be strong. This was a prestige contract, and across the world, some 6 major companies were in the running. Still, between WABCO and ourselves, we had over a century of experience in the transportation equipment field. Gathered round that table were men with a wealth of practical knowledge of the many facets of a mass transit operation. Specialists in the fields of signaling, communication and control systems, in engineering research, body design, wheel and rail production, in rail bed construction, traction equipment, heating and ventilating systems. 12 men, and behind them all the resources, know-how and skills in the many plants that constitute the Hawker Siddeley and WABCO complexes across North America, and specialists from the Foundation Company of Canada and Dillon Associates. Expo specifications limited train speeds to 45 miles per hour for sightseeing reasons. To handle 30,000 people an hour during peak periods, this meant trains must arrive and depart at stations every 2.5 minutes. Could this be done in comfort, and especially safety? It could. We would provide Expo with one of the world's first automated train systems. Train speeds would be programmed throughout the length of the right-of-way. Automatic security systems would be inbuilt. Expo Express was to be something special. She was to be the train of tomorrow.
August 21st, 1964. The Hawker Siddeley proposal had been accepted. Across the Expo site, work was well underway. As the months passed by, the pavilions started to emerge, and beyond the man-made islands, work was proceeding apace on the network of superhighways being pushed through Montreal and its approaches. It was now a race against time. All work had been contracted on the basis of a critical path reporting system designed to spot delays. It was now June, 1965. 697 days to go.
By September 1965, operations were well underway across the country in the many plants which constitute the Hawker-Siddeley complex. From our Dosco works in Sydney had come 10 miles of rail. Expo specifications had laid emphasis on the necessity of quietness of operation both inside and outside the train. Hawker-Siddeley resolved the problem in several ways. Special rubber fastenings would be placed to deaden vibration between the rail and the track, also between the tie and the surface beneath it, particularly where bridge or other hard surfaces were concerned. Expo Express was to be an electrically operated train drawing its power from a 600-volt third rail laid alongside the track. To further deaden noise and vibration, space around and in between the ties was to be banked above normal railroad specifications. Finally, and unlike many railroad tracks, each section was to be welded to the other.
It was December 1965. By now, other sections of the Hawker-Siddeley complex were swinging into operation as per plan. At Canadian Steel Wheel in Montreal, another of Expo Express's component parts was taking shape. One item amongst thousands, all destined for a common rendezvous, Fort William. For here at the can car plant, Expo Express was taking shape.
In designing Expo Express, we applied a lot of the engineering research that had produced the Toronto Transit Commission's subway cars. For instance, by doubling the length of cars and combining an aluminum alloy superstructure with a steel undercarriage, we had increased train operating efficiency by 1/3. Yet, the Expo Express design involved additional challenges. Its windows were to be abnormally large, designed to give passengers a maximum view of the pavilions and sight. This left us relatively small areas of car body in which to achieve structural strength. These had to be specially reinforced. The large amount of glass area also required our boosting the air conditioning system in order to cope with added heat from the sun. Then again, both floor, wall, and roof surfaces had to be treated with insulation for sound deadening. Another important specification had been that the trains must be designed for maximum resale value once Expo 67 was over. Expo Express must not only be a train of the future, but she must be able to operate on standard subway lines as well. This necessitated the installation of a dual control system. On a standard rapid transit train, power is picked up by a shoe riding along the third rail. Expo Express had been equipped in this manner. Power from the 600-volt third rail is then normally transmitted to a manual control panel and from there to the train's electrical traction motors. Acceleration or reduction of speed is achieved manually. Expo Express's design was to incorporate all these standard features. In addition, however, she was to have built into her an automatic control system. 2 systems and miles of wiring. As train after train rolled off the assembly line, a multitude of circuits had to be checked and double-checked.
It was now March 1966. 424 days to go. On the Expo site, WABCO technicians were laying down the network of cables needed to make Expo Express the first automated rapid transit train in the Western Hemisphere.
The principle was deceptively simple, yet it was the result of years of research by WABCO. We would control the train by signals fed directly into the rails and picked up by the train as it moved along them. Each section of the right-of-way was divided into zones with permissible speeds allocated to each zone for safety and sightseeing reasons. This information would be translated into electronic signals in instrument rooms controlling each section of the right-of-way. These signals would then be sent to various sections of the rail. As Expo Express advanced along the line, its scanner would read the signals coming from the rails beneath it. These in turn would activate a velocity control programmer aboard the train. The VCP would translate these signals into acceleration or braking instructions to be transmitted to the train's traction motors and braking system. Built into the system were a series of safeguards. The physical presence of Expo Express in any one zone would change the signals in the areas directly behind it, thereby avoiding the danger of rear-end collision. Signals would revert to normal once the train had vacated a zone. Wayside coils placed at the approaches to each station would trigger off a programmed decrease in speed until the train came to a full stop. Area of tolerance, 1.5 feet. Finally, information on the position of all trains would be electronically displayed on a panel in an operation control center. The control officer would be in constant two-way voice communication with the motorman on each train.
It was now May 1966. 363 days to go. Across the man-made islands, Expo 67 was starting to take shape. And 1,800 miles away at Fort William, a debutante was being presented to society. Expo Express.
She'd been 21 months in the making, but there she was, sleek, long, and spacious. The train itself was to consist of 6 cars. Each car would have 84 seats and room for 120 standing. Train capacity, 1,200 people. As she started on her maiden journey towards Montreal, we could be excused a certain pride in what we'd achieved. Railwaymen are a strange breed. We tend to talk of trains like girl watchers do of the female sex. By any standard, Expo Express got top marks. She was fast, yet safe. Sleek of line, yet comfortable. She could move quietly. In stop after stop on the way to Montreal, she collected admirers. And in Montreal itself, her arrival was an occasion.
was now September 1966. 240 days to go. The Bridge of Isles, another Hawker-Siddeley project, had been completed. Across the length and breadth of the site, the futuristic shapes of the pavilions were rising against the sky. The sharp thrusting lines of the A-shaped steel pavilion as well. Ontario, a series of cones. The geodesic sphere of the United States of America. It was a mixture of traditional and super modern design.
In October, we started the first trial runs, an important date for us at WABCO. It's one thing to design and construct such an automated system. It's another to check it out and make sure that everything works out perfectly. We started out with a check of the manual control system.
You may proceed. Over.
Testing communication system. Audio read me. Over.
Rendezvous 67, this is train number 8. Read you loud and clear.
Rendezvous 67. This is train number 8. Go into Laronde Station.
Understand you are on track 8. Over.
Rendezvous 67. This is train number 8. We are now at Laronde Station. Could you clear us out for a run in automatic?
Train number 8, you'll have to wait a couple of minutes.
The manual control system had checked out.
Rendezvous 67.
Ahead
we
lay the
have
greater
tried the
challenge,
doors and everything seems
the
normal
automated
here.
system.
Have you cleared me for an automatic run from Laronde to Notre Dame?
Your switches are now on a straight line. You may proceed as soon as you want to.
Speed. 12.
Train seems to be operating normally at the required speeds.
24. 30. 34. 40. 45.
I am now into the curve, number 7 curve at 25 miles an hour.
13 curve. 12 25. Entering curve. Accelerate to 30.
Things are going very well here.
Approaching station. Trigger coil. Program stop.
It had worked. Ahead of us lay the job of testing out each train, each section of the right-of-way. But as Expo Express started into that second lap, we knew that it was only a routine matter.
Hawker-Siddeley and WABCO had met the specifications, and Expo Express, the train of the future, had become a reality. Contract completed, file for future reference.